when benzene is treated with a nitrating mixture. So nitrating mixture is nothing but a mixture of concentrated nitric acid and concentrated sulfuric acid. COCH3 group gets attached to the benzene ring forming acetophenone, along with that hydrochloric acid. And when it comes to combustion reaction, when heated in air, benzene burns with a sooty flame producing carbon dioxide and water. Hello dear students, I am Roja, your chemistry lecturer from Vidhyaashram PU College, Temple of Excellence, Mysuru. Now we shall continue the chapter Hydrocarbons. So in the previous session we have learnt about alkynes, their nomenclature and isomerism, preparation of alkynes, then physical and chemical properties of alkynes, and also we have started with aromatic hydrocarbons. Now in this session we shall continue the physical and chemical properties of aromatic hydrocarbons as well as carcinogenicity and toxicity. So let us understand what are the properties of aromatic hydrocarbons. So the physical properties includes nature, their state and color, then solubility and also about combustion. So physical nature is they are non-polar molecules. Their state and color is they are usually colorless liquids or solids, and they have characteristic pleasant smell. Example is naphthalene balls, which is used in toilets and cupboards for moth repellent action, and also it is recognized by their strong smell. Solubility includes they are insoluble in water due to their non-polar nature, and they are miscible in organic solvents like benzene, ether, alcohol, etc. So how about combustion is it burns with a sooty flame due to high carbon content in the aromatic hydrocarbons. So let us now see the chemical properties of aromatic hydrocarbons. So arenes are characterized by electrophilic substitution reactions. However, under special conditions, they can also undergo addition and oxidation reaction. So under electrophilic substitution reaction, arenes undergo electrophilic substitution reaction wherein the attacking reagent will be an electrophile. So major reactions include nitration, halogenation, sulfonation, Friedel-Crafts alkylation as well as Friedel-Crafts acylation. So in that first one we shall know about nitration. So in this nitration process, a nitro group is introduced into the benzene ring when benzene is treated with a nitrating mixture. So nitrating mixture is nothing but a mixture of concentrated nitric acid and concentrated sulfuric acid. So this nitro group will get attached to the benzene ring forming nitrobenzene. So the second type of reaction involves halogenation. Here arenes react with halogens in the presence of Lewis acid like anhydrous ferric chloride, ferric bromide or aluminium chloride to yield haloarenes. So when benzene reacts with chlorine, here chlorine is taken as an example, in the presence of anhydrous aluminium chloride. So chlorine is going to attack benzene ring forming chlorobenzene along with that hydrochloric acid. So that was about halogenation. Now coming to sulfonation, the replacement of a hydrogen atom by a sulfonic acid group in the ring is called as sulfonation. It is carried out by heating benzene with the fuming sulfuric acid, that is also called as oleum. Example, when benzene reacts with fuming sulfuric acid, the sulfonic acid group gets attached to benzene ring forming benzene sulfonic acid along with the water as a byproduct. So next type of reaction is Friedel-Crafts alkylation reaction. So when benzene is treated with alkyl halide in the presence of anhydrous aluminium chloride, alkyl benzene is formed. So benzene on reacting with methyl chloride in the presence of anhydrous aluminium chloride, this methyl group is going to attack the benzene ring to form toluene. This is also called as methyl benzene along with that hydrochloric acid. The second example can be given as this is ethyl chloride. So this ethyl group gets attached to benzene ring forming ethyl benzene along with that byproduct hydrochloric acid. The next type of reaction is Friedel-Crafts acylation reaction. Here the reaction of benzene with an acyl halide or acidic anhydride in the presence of Lewis acid, it yields acyl benzene. For example, benzene reacting with acetyl chloride in the presence of Lewis acid, that is anhydrous aluminium chloride, the COCH3 group gets attached to the benzene ring forming acetophenone along with that hydrochloric acid. Another example is acetic anhydride reacting with benzene yields again same acetophenone, but along with that byproduct we get is acetic acid. So next type of reaction is addition of hydrogen. So in the presence of nickel catalyst at 180 degrees Celsius, benzene undergoes hydrogenation to give cyclohexane. So benzene consists of 3 pi bonds. So these 3 pi bonds are attacked by hydrogen, that is 3 hydrogen molecules, to form cyclohexane. This is hexane molecule. So the product we get is cyclohexane. And when it comes to combustion reaction, when heated in air, benzene burns with a sooty flame producing carbon dioxide and water. So benzene, on reacting with oxygen, it yields carbon dioxide as well as water. So this is the actual reaction between benzene and the oxygen. The next type of reaction involves addition of chlorine to the benzene ring. So benzene undergoes addition reaction with chlorine in the presence of sunlight. That gives benzene hexachloride, that is having a formula C6H6Cl6. So that also has a different name, that is BHC or gamaxane or indane, which is used as an insecticide or a pesticide. So benzene has got 3 pi bonds again. 3 chlorine molecules are going to attack the pi bonds, forming a cyclic structure. The formula is C6H6Cl6. So the name of the compound that we get is benzene hexachloride. So in short, we can call it as BHC. So let us now understand about resonance structure of phenol as well as nitrobenzene. So in phenol, that is having a benzene ring with OH group. OH group consists of lone pair of electrons that will donate it to the benzene ring. So when a lone pair is donated to the benzene ring, it forms a double bond between OH group and the benzene ring, and the pi electrons will shift towards the adjacent atom. So this type of delocalization of pi electrons happens in the benzene ring. Therefore, ring gains extra electron cloud density at ortho and para position here, as you can see in the structure. Making it possible to have electrophilic reaction. So that can be reacted with the electrophile. So the more easier will be the reaction. Hence, phenol shows resonance between OH and the benzene ring. So making it as a more reactive compared to the benzene. So that was about resonance structure of phenol. So when it comes to resonance structure of nitrobenzene, the formula is C6H6NO2. Here nitro group is going to attract electrons towards itself from the benzene ring. So it is going to, so the pi electrons are being shifted towards the bond between nitro group and the benzene ring, making it electron deficient at the sites. So this makes electron poor at the sites of ortho and para position. So therefore nitrobenzene is a meta-directing compound. So that was about aromatic hydrocarbons. Now we shall move on to the topic carcinogenicity and toxicity. Benzene and polynuclear hydrocarbons containing more than 2 benzene rings fused together are toxic and said to possess cancer producing properties, that is carcinogenic property. Such polynuclear hydrocarbons are formed on incomplete combustion of organic materials like tobacco, coal and petroleum. They enter into human body and undergo various biochemical reactions and finally damage DNA and cause cancer. So example includes 1,2 benz anthracene, so 3-methyl cholanthrazine or 1,2 benz pyrene. So these are toxic to the human body. So that was about hydrocarbons. I hope you have understood the chapter. Thank you.